Hello, everyone. My name is Dylan Craine. I come from a computer science and software development background. When it came time for a career change, I was interested in data science for a number of reasons. But one of them was that I thought that data science might be a great way to gain some ground on a personal ambition of mine, which is to do everything in my power to defeat human aging, which is a pretty big problem. But so I felt that when I came time to choose a capstone project, I wanted to do something that would at least start to be relevant to that issue. So I decided to look at GeneRIFs. GeneRIFs are short summary sentences of genes that explain the function of the gene. Here are some examples of GeneRIFs. And so my goal was to take these GeneRIFs and this database called GeneDR, which is a database of genes that are specifically thought to be related to this effect, where if you give, it's been mostly observed in mice, but in some other animals too, where if you feed them an extremely low-calorie diet that is not so small that you starve them, but is no larger than it needs to be, then they actually have extremely extended lifespans. So these are genes that are thought to be related to that, responsible for that, associated with that effect in some way. So my goal was to take the GeneRIF text for these genes that are thought to be related to the dietary restriction effects and GeneRIF text from a whole bunch of other genes that don't necessarily have anything to do with it, and build a model that could predict, based on the GeneRIFs, whether or not a gene might be relevant to this problem, with the goal of maybe being able to look at the unrelated GeneRIFs and find genes that were not in the GeneDR database but maybe still could be in the GeneDR database. And my secondary goal was to do some clustering on specifically the GeneDR GeneRIFs and see if I could find some interesting categories, maybe shed some light on the research that's been done, maybe find some holes in the shape of the research that's been done so far. So I built a naive Bayes model. I had very unbalanced classes. There are only about 2,000 GeneRIFs for the genes in GeneDR, but for all of the genes, there are a million GeneRIFs. So I trained my model on roughly 2,000 RIFs from the non-GeneDR genes and the 2,000 RIFs from the genes that are in GeneDR. And it did quite well, actually. I got 90% accuracy. So that's pretty good. And I found 40,000 potential genes, that's over all organisms, that were not in the GeneDR database, but maybe they could be. And so here's a cloud of some of the words that my model predicted as being especially important for predicting GeneDR genes. And I've got some good ones in here. I've got longevity, aging, sort of the no-brainer gimmies. I would hope that they show up in this list, and they do. So that gives me some confidence that probably these other words are also important, even the ones where it's less obvious why they would be. And for the second part of my project, I did some non-negative matrix factorization, and I got some good categories here on the GeneDR, specifically GeneRIFs. I've got, here's one on oxidative stress. Here's one on stem cells. So, and that is my project. I would love to answer any questions.
Really interesting stuff. So calorie restriction is great, living longer is great, but it kind of sucks while you're doing it, right? So how would you use something like this to try to get all of the benefits of calorie restriction without having actually to restrict your calories?
Well, I think that would take probably a lot more research. This will give us a little bit more focus on what genes we should be looking at and how they might impact the calorie restriction thing, so that we can figure that out, what we can do to get those benefits without having to actually do the dirty work. But I don't have any direct answers from this, of course.
This is really cool, especially like that it involves language analysis, something near and dear to my heart. One of the things that I saw is that some of the RIFs would say something like, this gene is not related to such and such a thing. And so one of the challenges that we have when we process language is that words are compositional, right? So when I say I am not happy, it means something very different from when I say I am happy, even though most of the same words are in that sentence. So do you have a sense for whether or not your model is able to kind of capture those relationships between the features that maybe could be best captured with like a hierarchical type of analysis?
Well, I think that for most of the GeneRIFs at least, they tend to be positive statements. They tend to say, here's something we do know about this gene, that it does work in this way. And since the GeneRIFs in general are not specifically concerned with calorie restriction, and I'm just looking at the ones that are versus the ones that might be. So I didn't look too hard at that, because I think for GeneRIFs at least, that's maybe not an issue.
Cool, interesting work.